Alrighty, my people, hope we're doing well. In the last video, we talked a little bit about properties of logarithms, and we did some expansion problems. In this one, I'm going to do several examples of the opposite process, which is putting them back together. And yeah, that'll be that. Alrighty, let's go ahead and start with one that is, not too difficult. So 4 natural log x plus 7 natural log y minus 3 natural log z. And as always, with any of these, if you have the desire to try them on your own, there is that really neat pause button. So just pause it while you try it, and then kind of see whether you're right. All right. Now from this one, I obviously have several different logarithms, and I need to condense them into a logarithm of a single expression. I have two positive ones and I have a negative one. That means I'm going to have two factors in the numerator and one factor in the denominator. But what I need to do first is I need to get rid of these coefficients out in front. Okay. And basically remember that all these properties, just like any identity or something like that, the logic goes both ways, right? So it's not just the fact that natural log of x to the n is equal to n natural log x. The logic doesn't just run that way, it runs that way as well, right? So basically what we're doing is we need to run the logic that way to the left, and basically take that coefficient and pop it up as those exponents. So you have the natural log of x to the fourth plus the natural log of y to the seventh minus the natural log of z cubed. And of course, remember, this one is understood to be positive. And so you have the natural log of x to the fourth, y to the seventh over z cubed. And if you want to put that in parentheses so that it looks a little bit tidier, then that's just fine. Remember, the parentheses are only necessary when there's some sort of ambiguity, right? If I have the natural log of x minus 2, that is not the same thing as the natural log of x minus 2. The argument is the x. So it's the natural log x and then minus 2. Here the minus 2 is included in the argument, okay? So be very careful with the parentheses. Sometimes they do just tend to neaten things up and make them look a little bit tidier. Sometimes they are absolutely essential. So just, be mindful of that as we move forward, okay? Alrighty, let's do another one. What do you say we do? Oh, I like that one. Let me get my glasses on so Okay, so this would be 1/3 log base 4 of x minus log base 4 of y plus 2 log base 4 of x plus 1. Now, here's the thing. There are several ways that you can go about doing this. And I would suggest that you kind of use the same sort of method all along. I like to think of all of the factors as independent of each other. But you could, take this as 1/3 log to the base 4 of x over y plus 2 log to the base 4 of x plus 1. And then this becomes log to the base 4 of x over y to the 1/3, or the cube root, it doesn't really matter, plus log to the base 4 of x plus 1 squared. And so you could have log to the base 4 of x plus 1 squared times the cube root of x over y, or something like that, okay? That's fine. I would encourage you instead to basically take these parentheses, distribute the 1/3, break them apart, so that you can deal with each of them independently. That winds up being a way that fewer careless errors kind of creep in. And so once you've done that, you've recognized the fact that you have 2 positive logs and 1 negative. And so you get the positive log of 4 times the cube root of x, or x to the 1/3, however you want to do it, cube root of y, plus log to the base 4 of x plus 1 squared. And I'm going to turn it back into 1/3 when we turn it into this full logarithm, just because I probably should have done that in the first place. And so you get x to the 1/3, x plus 1 squared over y to the 1/3, and you can put parentheses or brackets around or something like that. Now this is equivalent to that. They are the same thing, okay? But just because it basically, you have to figure out which way your brain wants to do them, which way it makes more sense. For me, it was always a break it apart into all the little pieces first and then put them back together independently, and just, unless I'm required to do so, don't worry about how the pieces necessarily fit, the pieces meaning the factors of the argument fit together, because oftentimes it doesn't matter and you shouldn't care, right? So there's that. All right, let's go ahead and do another one. Okie dokie. How about log of x and log of x squared minus 4 minus log of 15 minus log of x plus 2. Now, that is a weird place to start with if you're being asked to condense, largely because that isn't fully expanded, right? And you should recognize the fact that that's log of x plus 2 and log of x minus 2, right? These two basically go into that logarithm. Well, that wouldn't actually be necessary to recognize, except this right here cancels with this right here, and that's probably a pretty good thing to do before you ever even get started, okay? So what we have here is we have log x plus log of x plus 2 plus log of x minus 2 minus log of 15 minus log of x plus 2, and boom, boom, those cancel out. Now, here's the thing. They are terms here. Once you actually condense it, they would be factors of the argument, and of course the argument would have a rational structure since I have both positive and negative logarithms here. So you can cancel them out as terms here up front, or you just need to be able to recognize that they cancel as factors once it's all together in terms of a single logarithm of that large rationally structured argument. Okay, so for here, this winds up being log of x minus 2, all of that over 15, and that is my answer. Now, if I hadn't recognized this, I could have just started from here, minus log of 15 minus log of x plus 2. So I'll show you what I mean by they would have just canceled as factors. So you get log of x and x squared minus 4 over 15 and x plus 2. Now that's all well and good, but implied within the x squared minus 4 is, of course, both of those linear factors, the x plus 2 and the x minus 2, which would then basically cancel as factors here, whereas they canceled as terms up here, and you still wind up getting log of x minus 2 over 15 as your answer, okay? Alrighty, let's do one more, and of course I've already tipped my hand, so you probably know what's coming, but let's have fun with it nonetheless. Let's say we have log base 3 of, x plus 2 minus 2 log base 3 of y plus, 1/2 log base 3 of z plus 3 minus 2. Okay, now here's the thing. Log base 3, log base 3, log base 3. The thing that doesn't match is here. Right? But if we're putting them together, we should remember that we've actually taken a condensed logarithm, expanded it, and actually evaluated some of the numerical logarithms to get integer or rational or whatever terms. So if you have an integer or a rational term, we've been unsimplifying before. I guess you can sort of unevaluate it, right? Because what you're really doing is you're multiplying by 1 in a creative way. And basically this is 2, but it's also 2 times 1, and that can be log base 3 of 3. Right? You strategically put that in there and all you're doing is you're multiplying by 1. You're just multiplying by 1 in a really creative way. And what happens here is you get log base 3 of x plus 2, that's a positive log, minus log base 3 of y squared, plus log base 3. And you can do square root of z plus 3 or z plus 3 to the 1/2. Let's just do it in fractional exponents. And this winds up being log base 3 of 3 squared, or 9. Because log base 3 of 9 is 2, right? It is simply an unevaluated logarithmic version of 2. And that's kind of what you were looking for, okay? And so I have 2 positive and 2 negative. I'm going to get log base 3 of x plus 2 z plus 3 to the 1/2 over 9y squared, and that is how it would condense. That's how we would kind of put it together. Okay. That's it for rules of exponents and properties of logarithms. I don't see the need to do it any further. I just want to have enough of an exposure that we are sort of refreshed in our understanding of these things. Sort of knock the dust and the cobwebs off from the summer, because I mean you were doing math over the summer, but it was trig, and so I just wanted to have these out there because it's better to have them and not need them than need them and not have them. But the next videos will be on z problems, or what are usually referred to as literal equations. So it looks like formulas where you're solving for a particular variable. And that will sort of bring us to the end of the videos for our calculus readiness unit. If you have any questions, please do shoot me an email. Bye.